part of this week's homework is going to be using truth tables to test for properties of sentences and arguments. And I'm going to do a couple of sample problems here to give you a sense of how that works in Carnap, and also to give you a sense of how it works in general. So the first problem is to consider the sentence not P arrow Q or Q arrow P. And we have the truth table automatically set up for us in Carnap. And it's filled in the columns for the sentence letters. So we have to work at the smallest parts. That's going to be these conditionals first. So the conditional only gets a value of 0 when it's 1 arrow 0. That's here and here. And it gets a value of 1 for all the other combinations. Of course, if you want, you can look up each of those possible combinations on the characteristic truth table if you haven't gotten it memorized yet. Now we have values for the two conditionals. We're putting those together as a disjunction. And it gets a value of 1 provided there's at least one of the two that's a 1. 1, 1, yes. So we're looking at this column and this column. 1, 1, yes. 0, 1, yeah. 1, 0. 1, 1. So now that we've calculated the disjunction, we can go to outside these parentheses and calculate the negation. It's the opposite. All those 1s become 0s. Now, Carnap lets us click check, and it says success. We've done the table right. And it turns the thing green to let us know that we've done it right. If you've made a mistake in the truth table, it'll tell you if you've made a mistake, and you can go back and fix it. Once you've done the truth table correctly, you can submit it and get credit for it. Now we're asked, what kind of sentence is this? And for that, we look at the main logical operator of the entire sentence, which is the negation. It gets a 0 on every row, and that means it's a contradiction. And again, if this were a homework problem, you'd click submit, and your answer would be recorded. So those are sentences. For arguments, we can do truth tables for those too. So the homework says, or this problem says, consider the argument. S biconditional not T, therefore S or T. And we look down, Carnap has set it up as a truth table. The only slightly confusing thing is this here, where Carnap uses the double turnstile symbol instead of the 3 dots for the therefore. But this is actually a column representing therefore. And I'm going to complete the rest of the truth table and then explain how that works. So what we've got first is 2 separate sentences. We'll start with this one. So we can start with the not T. And now S biconditional not T. Same value gets a 1. Same value gets a 1. Different values gets a 0. So now we can come over to the conclusion. This is S or T, and it gets a 1 if either or both of them is a 1, and it gets a 0 otherwise. Now this column represents the therefore. We're checking to see whether the premises are true and the conclusion is false on this line. And it's not. Here, the premise is false. So this row is compatible with the argument being valid, and we give it a check. On the second row, premise is true, conclusion is true. Well, that's compatible with it being valid. We give it a check. 1 and 1. That's compatible with it being valid. 0, 0. Again, compatible with it being valid. So we check, and Carnap says, yes, we've filled out the truth table correctly. I'd submit my work. So what this check is doing, the options are check or X, where an X would mean we'd found a row where the premises were true and the conclusion was false. That is, we'd found a row which showed that it was invalid. But we did the complete truth table, and none of the rows were like that. They were all compatible with it being valid. And so that means the whole argument is valid. We'd submit that, and we'd be done. Of course, you're going to be asked about multiple sentences and multiple arguments, but the kind of problem is the same, and it works in the same ways. If you have trouble with it, feel free to reach out and ask for help.